Some weapons fail on the battlefield. Others fail so catastrophically that the military tries to scrub every trace of their existence from the record. Today, 10 weapon systems so secret, so disastrous, or so absurdly misguided that they were almost erased from history. The first one was designed to win a war with a giant wheel. Panjandrum. In 1943, the British Admiralty's Directorate of Miscellaneous Weapons Development faced a brutal problem. The Atlantic Wall was 10 feet thick and 7 feet high of solid concrete. Delivering a 1-ton explosive charge by hand onto a killing ground beach was suicide. Their solution was a 10-foot steel drum packed with explosives, suspended between 2 wooden wheels, each 10 feet in diameter and 1 foot wide. 70 cordite rockets were clamped to the rims. The math was simple: ignite the rockets, achieve 60 miles per hour, and smash through the wall with sheer kinetic force. Sub-Lieutenant Neville Shute named it after a nonsense poem, a decision that proved prophetic. The fundamental flaw was the impossibility of synchronizing 70 unguided rockets. Each rocket burned slightly differently, creating asymmetric thrust. The instant one will receive more impulse than the other, the 30-ton monster turned violently. On every test, cables snapped, rockets tore free, and the wheel careened wildly off course. During a final demonstration for Navy officials in January 1944, rockets detached and flew over the heads of diving admirals. The prototype disintegrated on the sand in a hail of violent explosions. The weapon was scrapped immediately over safety concerns, though one theory suggests it was a brilliant hoax for Operation Fortitude, merely convincing the Germans that an attack on Calais was imminent. M247 Sergeant York. In the late 1970s, the U.S. Army faced a deadly problem. Soviet attack helicopters like the Mi-24 Hind could pop up from behind terrain, fire a missile with a range of up to 5,000 meters, and vanish in seconds. The Army's existing air defense was a stopgap pair, the M163 Vulcan with a 20mm cannon, effective only to 1,200 meters, and the Mi-72 Chaparral missile, which required a lengthy lock-on period that made it useless against fleeting targets. Neither could keep up with the new M1 Abrams tank across rough terrain. The Army rushed a solution called DIVAD, Division Air Defense, skipping normal development to use off-the-shelf parts. Colonel Russell Parker told the Senate Armed Services Committee in March 1977 that this unorthodox approach would cut up to 5 years from the development cycle, accepting higher but acceptable risks. Ford Aerospace won the contract, mounting twin radar-directed Bofors 40mm rapid-fire guns on a surplus M48 Patton tank chassis. The system was named after World War I hero Sergeant Alvin York. The core requirement was simple: detect a pop-up helicopter, track it automatically with radar, and destroy it before it could fire. The radar was the brain of the machine. And that brain was blind. During testing at Fort Bliss, operators pointed the Sergeant York at a hovering helicopter. The radar locked onto a spinning latrine ventilation fan on a nearby outhouse instead. The problem was fundamental. The fire control radar could not distinguish a rotating helicopter rotor from any other rotating metal object. It saw the world as a collection of moving reflections and classified them all as targets. Trees waving in the wind generated false tracks. Ground clutter from the desert floor overwhelmed the signal processor. The system was designed to filter out stationary objects, but any movement, a truck, a barrel, a bathroom fan, triggered a firing solution. In one demonstration before Congress, the turret spun wildly, aiming its guns at the reviewing stand full of generals and lawmakers. The radar had locked onto the spinning blades of a ventilation unit on the VIP tent. The cost spiraled. A program initially budgeted at $1.8 billion ballooned. 50 vehicles were built. Not one worked. In 1985, the Secretary of Defense canceled the entire project. 50 Sergeant Yorks went to the scrap yard without ever firing a shot in combat. K-19 submarine. In the late 1950s, the Soviet Union rushed to build its first nuclear ballistic missile submarines. Speed was prioritized over safety. K-19 was ordered on October 16, 1957. Her keel was laid exactly 1 year and 1 day later. The main flaw was not a single broken part, but an entire construction philosophy. Haste meant deadly shortcuts. The primary cooling system for the nuclear reactor had a backup system in the blueprints, but it was never installed. Without coolant, a reactor's decay heat soars uncontrollably toward a meltdown, a catastrophe that could turn the vessel into an underwater radiological bomb. This exact failure happened on July 4, 1961, during the boat's maiden voyage. The pressure in the starboard reactor's cooling system dropped to zero. A major leak caused the coolant pumps to fail, and the reactor temperature rocketed to 800 degrees Celsius. The captain ordered the engineering crew into the reactor compartment to jury-rig a secondary coolant system by welding a water supply pipe to a cut air vent valve. The men worked in lethal radiation without a backup plan. The repair crew later discovered the exact cause: a welder, cramped in a tight space years earlier, had failed to protect a pipe with asbestos drop cloths. A single drop from a welding electrode created an invisible crack. Subjected to over 200 atmospheres of pressure, the pipe ruptured. The accident killed 7 engineers within a month. 15 more sailors died within 2 years. K-19 limped back to port and was repaired, but the crew had already given it a new name: Hiroshima. Mark 14 torpedo. In 1931, the U.S. Navy allocated $143,000 to design a new submarine weapon. The Mark 14 was 20 feet 6 inches long, carrying a 507-pound warhead at a top speed of 46 knots. It was guided by a continuously powered gyroscope and fitted with the top-secret Mark 6 magnetic influence exploder. The exploder was designed to pass beneath a ship's keel, where there was no armor, and detonate using magnetic field detection. This project was developed, in the Navy's own words, behind the tightest veil of secrecy ever created. The manual was locked in a safe. And then the weapon was sent to war without a single live-fire test. A live warhead test was proposed using an obsolete destroyer, but the Bureau of Ordnance declined, unwilling to risk sinking the hulk and paying to refloat it. The result was a weapon that failed in 3 fundamental ways. It ran roughly 10 feet deeper than set, causing it to pass harmlessly under targets. The magnetic exploder was calibrated for the North Atlantic, not the equatorial Pacific, so it often detonated prematurely or not at all. The contact exploder, reliable at 30 knots, failed at 46 due to the increased impact force. Submarine commanders returned from patrols reporting perfect hits and 0 explosions. The Bureau of Ordnance blamed the captains for 2 years before finally acknowledging the defects. 233 Mark 14s were destroyed in a single air raid on Cavite Navy Yard before the problems were fixed. V-2 rocket. By September 1944, Nazi Germany began launching the world's first practical ballistic missile against Allied cities. The weapon was a technical marvel. Its liquid propellant engine burned a mixture of 75% ethanol and liquid oxygen, fed by a steam-driven turbopump spinning at 4,000 revolutions per minute. This pump forced 125 liters of fuel and oxidizer into the combustion chamber every second. The gases inside reached 2,820 degrees Celsius. At launch, the 13.5-ton rocket rose on a column of fire, producing 25 tons of thrust. It would power itself for up to 65 seconds, reaching an altitude of 80 kilometers before its engine cut out. From there, it continued on a ballistic trajectory, falling toward its target at supersonic speed. There was no warning before impact. No defense could stop it. The problem was not the engineering. The problem was the strategy. The guidance system was too primitive. The missile could hit a city, but not a specific target within it. It was a terror weapon, not a military one. Its 1-ton warhead was a random killer. The real horror was in its production. The rockets were built underground at the Mittelwerk facility by prisoners from the Mittelbadora concentration camp. The conditions were lethal. An estimated 12,000 forced laborers died in the factories. More people were killed building the V-2 than by its warheads, which accounted for roughly 9,000 deaths in London, Antwerp, and Liège. The program cost Nazi Germany enormous resources, draining its struggling war economy for a weapon with no strategic impact. Over 3,000 V-2s were launched. The Allies could not stop them. But the rockets could not stop the Allies either. After the war, captured hardware and the rocket's chief designer, Wernher von Braun, were scooped up by the United States in Operation Paperclip. The V-2's true legacy was not a Nazi victory. It was the space race. Novgorod Monitor. In 1870, Rear Admiral Andrei Popov convinced the Russian Navy to build a coast defense ship with a completely circular hull. The logic seemed sound on paper. A wider beam meant a shallower draft of just over 13 feet, allowing the ship to carry 12 inches of armor and two massive 11-inch rifled guns on a platform displacing only 2,491 long tons. The circular shape was supposed to be a stable gun platform, and in calm seas, it was. The roll rarely exceeded 8 degrees. The problem was everything else. The hull was a hydrodynamic nightmare. The blunt, circular form masked the water flow over the single fixed rudder so severely that the ship took 40 to 45 minutes to complete a full turn. In any current or severe storm, it was almost unsteerable. The crew's solution was to lock the rudder and steer using only the engines, which further crippled its already pathetic speed of 6.5 knots. The real myth, however, came from the guns. During gunnery trials in November 1874, the locks on the rotating turntables were too weak. When the 11-inch guns fired, the recoil physically spun the turntable. This led to the persistent legend that the entire ship spun uncontrollably in circles. The locks were eventually reinforced, but the damage to its reputation was done. The ship was a tactical failure, unable to hold position in a current or chase an enemy. Novgorod spent its career as a stationary battery, was decommissioned in 1903, and sold for scrap in 1911. Messerschmitt Me-163 Comet. In January 1939, the rocket pioneer Alexander Lippisch moved his team to Messerschmitt, bringing with him a radical tailless glider design. By 1941, the prototype was flying under rocket power, and in July 1944, test pilot Heini Dittmar pushed it to 1,130 km per hour, a speed record that stood for almost a decade. The machine was a wooden-winged interceptor powered by a Walter liquid-fueled rocket engine. It used two propellants, T-Stoff, a highly concentrated hydrogen peroxide, and C-Stoff, a hydrazine-methanol mix. These two liquids ignited violently on contact, providing thrust without the need for an ignition system. The problem was the T-Stoff itself. It was not just fuel. It was a corrosive agent that could dissolve organic matter on contact. Pilots wore special protective suits, but the real danger came from the aircraft's own plumbing. The fuel lines ran through the cockpit and were prone to leaking during the violent, wheeled takeoff dolly run. If a line cracked, T-Stoff would spray into the cockpit and literally liquefy the pilot. This happened to test pilot and fighter ace Oberleutnant Joseph Pose in 1943. A ruptured fuel line during a failed takeoff soaked him in T-Stoff, and he died from the exposure. The landing sequence was just as lethal. The Comet ran out of fuel after a maximum of 7.5 minutes of powered flight, becoming a glider landing on a retractable skid. Any unspent propellant sloshing in the tanks could mix on impact, dissolving the pilot or exploding the airframe. Roughly 370 Comets were built, credited with destroying between 9 and 18 Allied bombers, while losing 10 aircraft. But the real kill ratio was against its own men. More pilots died in testing and landing accidents from the corrosive fuel than the enemy ever shot down. The fastest aircraft of its time was a coffin sealed with a chemical fuse. Bob Semple Tank. In 1940, New Zealand faced a genuine existential fear. The fall of France meant Britain could spare no tanks for the Pacific, and a Japanese invasion seemed imminent. The country had no armored vehicle industry. The solution came not from engineers, but from the Minister of Works, Bob Semple. His idea was brutally simple: bolt a tank body onto a Caterpillar D8 crawler tractor. The design had no formal blueprints. The team worked from an American postcard showing a tractor tank conversion. The first prototype was built from mild steel in a public works workshop in June 1940. What emerged was a rolling failure of mechanical logic. The tank stood an absurd 12 feet tall, making it a colossal target. The armor was not armor plate, but corrugated manganese sheeting, chosen in the desperate hope it might deflect bullets. This added massive weight, between 20 and 25 tons, onto a tractor chassis never designed for it. The tractor's gearing restricted it to slow speeds, and the driver had to stop completely to change gears. The crew of 8 included a gunner who had to lie on a mattress on top of the hot, vibrating engine to fire his Bren gun. The vibration from the tractor made aiming the 6 Bren guns almost impossible and inevitably inaccurate. It was a tractor, not a tank, and it handled like one. 3 were built at a total cost of £10,225. Public ridicule was immediate and brutal. The tanks were never used in combat. One had its armor stripped and was sent to the Pacific in 1944 as a simple tractor. The rest were scrapped or returned to their original jobs. F-104 Starfighter. In November 1951, Lockheed's lead designer Kelly Johnson interviewed fighter pilots in Korea. They wanted a simple, lightweight interceptor with extreme climb performance. Johnson delivered exactly that. The prototype flew on March 4, 1954, and the F-104 entered USAF service in February 1958. It was the first production aircraft to reach Mach 2 and the first to hold simultaneous world records for speed, altitude, and time to climb. The radical design featured wings so short and thin they needed protective covers on the ground to prevent technicians from cutting themselves. The leading edge had a radius of just 0.016 inches. This was the core problem. The tiny wing surface generated almost no lift at low speeds. To stay airborne during landing, the aircraft relied on a boundary layer control system that bled high-pressure air from the engine over the flaps. If the engine failed, the wing stopped working. Landing speed was a brutal 210 miles per hour. A dead-stick landing was essentially impossible. The German Luftwaffe bought 916 of them for low-level ground attack, a mission the high-speed interceptor was never designed for. Flying fast and low in European weather, with an engine that could not tolerate a bird strike without turning the aircraft into a brick, proved catastrophic. From 1961 to 1989, the Germans lost 292 starfighters and 116 pilots. The public called it the Witwenmacher. The Widowmaker. The final F-104S was retired by Italy in 2004. Japanese aircraft carrier Shinano. Laid down in May 1940 as a Yamato-class battleship, her construction was halted after the carrier losses at Midway in June 1942. The partially completed hull was reordered as an aircraft carrier, a support vessel for fleet operations. By late November 1944, the conversion was still unfinished, watertight doors had not been fully installed, and many compartments remained open to the sea. Ordered to move from Yokosuka to Kure for final fitting out, she was also carrying 50 Oka rocket-propelled kamikaze bombs. Just 10 days after commissioning, on 29 November, the submarine Archerfish put 4 torpedoes into her starboard side. With vital watertight boundaries missing and a freshly assembled crew of 2,400 lacking damage control training, flooding spread through the hull unchecked. Pumps could not keep up, and the massive 69,000-ton ship lost stability rapidly. Over 1,000 men were rescued, but 1,435, including the captain, were lost. She remains the largest warship ever sunk by a submarine. The rush to move an untested, unfinished carrier had doomed it before a single aircraft ever operated from its deck. History is littered with secret programs that consumed vast resources only to vanish without a trace.